This is a demonstration to solve the parseNum question in exam number 2. The first thing to do is to unzip the zip file and then go into the folder. It's always a good idea to take a look at the C code first. The C code starts on line 5 and it ends on line 26. So 5 to 26 yank, and then we can go into the assembly file and just paste the C code. Then we can replace or insert the comment symbol at the beginning of each line of the C code, so that way the entire C program is commented out, but I can still see it when I'm writing the assembly code. As with any type of subroutines, the first thing that I always do is to define the necessary symbolic constants. So old EBP is 0, return address is old EBP plus 4, and in this case we only have one parameter, which is history. History is return address plus 4. As far as the main code is concerned, the first thing we always do is to push EBP, save the EBP. Then we can take a snapshot of the stack pointer into EBP. The exit code, which I will specify here, is the reverse of that. So we first want to move EBP back to ESP, then we pop EBP and perform the return statement. Now this subroutine has two returns. One is on line 29 and the other one is on line 24. So we know that we have to set the set register EAX differently somewhere in the code. So it's always helpful to designate the end of the subroutine with the end sub, so we can branch to that point when we specify the return statement. There are two local variables, one is result and one is ch, but I can basically do it without using these local variables. But just to illustrate how to use the local variables, we can go ahead and do it that way as well. So result is really not needed because we utilize the return value of read right away. The only thing that we need is ch. So we can specify ch to be old EBP minus 4. Oh, I had a typo here. There we go. And if we do use local variables, in addition to taking a snapshot of the stack pointer into EBP, we have to reserve that space. So we can say add long $ch to ESP, and that will reserve space for the local variable ch. Okay, so now into the C code, the first thing we have to do is to read a byte from standard in. So that's pretty easy to do. We move 0 into, we move 3 into EAX, system surface number 3. We move 0 into EBX to read from standard in. We move the address of ch into ECX. And to do that, we copy we copy EBP to ECX first, and then we add the displacement, which is ch to ECX. So now ECX has the address of the local variable ch. And last, we have we put 1 into EDX because that specifies the number of bytes that we'll read. Actually perform the system surface here. Now when system surface number 3 returns EAX contains the number of bytes that it will read, which is basically what this comment is saying, so I'm going to erase that. The conditional statement is trying to make use of result right away, which is already in EAX. We can compare long 0 to EAX. If it is 0, we want to branch around it, so we'll branch to end if, and we'll put, we don't want end if, we want else, and the else label is going to be right here, at the else case of the conditional statement. If the result is non-zero, we still have to compare the ASCII code of that we have just read. So this is pretty easy to do because we have a local variable now. So we can compare byte. It is important to remember we are comparing a byte instead of a long, because a character only has one byte. So we compare byte with the constant of the ASCII code of 9 from ch. But ch is a local variable, so it is still relative to EBP. We branch around to the else case if ch is greater than the ASCII code of 9. So we say ja jump if above to else. Last, we compare byte to the ASCII code of 0 with the character that we have read into, that the system surface number 3 has read into. If it is below, then we also branch to else. The recursion on this line is going to pass the parameter history times 10 plus ch minus 0, and whatever parseNum returns in this case becomes my own return value, which is actually pretty easy to set up. But we first have to set up the parameter. History times 10, we can use the mol instruction to do it. We can move history EBP into EAX, so that makes one of the operand needed for the multiplication operation. And then the other one is just a constant 10. We move constant 10 into EBX, and then we perform the multiply instruction with EBX. After the multiplication instruction, EAX has the least significant 32 bits of the product, which is the only part that we are interested in. So at this point we can push it on the stack, but let's go ahead and add ch to it. Ch is only a byte, so you cannot just say add long ch EBP to EAX, because that would not be extending the sign correctly. To extend the sign correctly, there are a few ways to do it. One way is to use add byte first. So we say add byte ch EBP. So we are adding an 8-bit character to, in this case, register AL, because we're using add byte, so we have no choice but to use that. Let's see. I don't think this will work out because I cannot individually address the other bytes in register EAX. So I'm gonna scrap this plan here, and instead I'll use a move long 0 into EDX. So I'm zeroing out the 32-bit register EDX, and then I move a single byte from CH into register DL, because that's the least significant 8 bits of EDX. Now I can add EDX to EAX, so the EAX becomes history times 10 plus CH, and we just have to subtract the ASCII code of 0. So we subtract the constant of ASCII code of 0 from EAX, and then we just push EAX on the stack. That becomes the parameter. Next, we just call the subroutine called printDec. It's parseNum. When it returns, those 4 bytes on the stack are no longer needed, so we reclaim it by adding 4 to ESP to balance the stack, and then it is time to return. Whatever parseNum returns to me in EAX is also what I want to return to my own caller. So there's nothing to do with EAX. We just have to branch around the else case to end sub, and we are done with this case. The else is also easy to implement because we only want to return the value of history. And to do that, we move long history parent EBP to EAX, because that's how we specify the return value. There's no need to branch to end sub, because it will just fall through to that label. So we'll go ahead and see if this will assemble. No problem. And we'll run it with the test file. It prints 1 to 3, which means the code is working correctly.